Welcome back to Microsoft Ignite Live. I'm Seth Juarez, getting ready to dive into some of the key concepts on how to build high-performance, highly available applications in the cloud. And to do it right, I have Mark Brown jumping in with me. How you doing, buddy?
I'm good, Seth. How you doing?
So look, here's the standard thing. When it comes to building distributed systems, I have heard that whenever you have a computer problem and you use distributed systems, now you have two problems.
That's correct, you do.
Yeah, and it's a very hard thing to do. So why don't you help us out and educate us, or me, hopefully, with some of the distributed system principles that we need to think about before we start building these big applications.
Sure. So why use distributed systems or build distributed systems in the first place? And there's really two fundamental reasons. One is for higher availability. What happens if a region becomes unavailable or something becomes unavailable? You need to have other copies or other instances of that application up so you can continue serving requests to customers and hopefully selling your goods or providing whatever services you need. The second reason is for latency, right? The closer you can get your data to your users, the faster your applications are going to respond, right? Packets don't need to travel so far. They can go much shorter distance and then come back to the client much, much quicker too.
So let's talk about, because obviously with the advent of the cloud, we have availability of so many resources that we can use to build our applications. What are some things that I should be thinking about? I know you talked a little bit about regions, but can we dive into, here I am, Seth, I'm going to build a new application that I want it to be available and have not a latency problem. What do I need to do in Azure to do that?
Well, first, if you want higher availability, you got to deploy your application into multiple regions. And then you need to load balance them, or load balance over them. So using a DNS load balancer, like a traffic manager, is something you're going to need to be able to make sure that your customers are going to the region that's closest to them, or if a region becomes unavailable, it's going to redirect to that other region. You need resiliency within region too, not just across region. So deploying multiple instances of your web front end, multiple instances of VMs or whatever. And you should do that at every tier. And then on the back end, you want to use a data store that's going to provide both that in-region resiliency as well as provide replication across regions, and that's Cosmos DB. Cosmos is fully managed. We provide in-region resiliency for your data with 4 copies, 4 replicas of your data, and then we replicate. We're in every region, so Cosmos is a Ring 0 service. You just add regions into your account, and then we replicate all of your data across those.
And I mean, that's awesome, but I heard a lot of terms, and now help me out, like, because I'm the dense guy here. If I'm building, let's just say I'm building a new application, it's a web application in my storefront, and I'm new, and I want to make sure that this thing is both available and has low latency. Like, what do I do? Am I just spinning up everything in different regions? How do I coordinate all this stuff?
Well, a couple of things you need to keep in mind is when you have data in multiple regions, you need to provide consistency for that data. Some may require strong consistency or maybe eventual consistency, and there's levers in between that as well. It's important to keep in mind, there's a theorem called CAP theorem that anybody that's building a distributed system should understand, and what that says is I have a choice between consistency for my data, which means it's the same in every region or every node, or availability for that data too. So I have to make a trade-off between those two things. Can I have dirty reads or inconsistent data, or do I have to be strongly consistent? Because I can't have both of those things.
I see.
Right.
So if I'm building a web app, do I have to think about those things, or is there something do I just spin it up in 2 different regions, and then what do I do? You said traffic manager, but that's not something I've used before, for example.
Oh, you haven't?
No, describe what that is. I'm trying to figure out, it's like I spun up a website the other day about cats and stuff, and I want everyone to look at it, because obviously everyone loves cats. What is it that I'm doing when I'm spinning these things up in different regions? Do I just turn it on and then everything happens?
You need to configure your regional endpoints then, and then you use Traffic Manager and its domain name, and then let Traffic Manager route those requests to either the right region, or you can round robin it if you want, or just use it in a failover mode as well, so for high availability disaster recovery.
And so basically there's some services in Azure that help you do that, but you have to be intentional about it.
Correct. And if you're building for the cloud, you fundamentally should be building a distributed system because you want that availability, or you want that low latency for your users.
I see. So we've talked a little bit about some principles of distributed systems. We talked about some things to think about when you're doing these things in the cloud, like for example, multiple regions and making sure that the data is close to where the reads are happening. I don't know if you said that, but I'm guessing that's what you mean by latency. What are some services in Azure that do this for us? And you mentioned one, Cosmos DB, but why don't you dive into how it's helping us do this correctly?
Right, so at the heart of Cosmos is replication, right? So we can globally replicate your data into every region in Azure. We also provide consistency levels that you can choose. So there's 5 different consistency levels you can choose within Cosmos that's going to provide predictable performance, because the consistency level you choose has an impact on the throughput for your applications. But also predictable in terms of how consistent your data is and how quickly it's consistent within there as well. So if I use strong consistency for my application, that means that every write I make into my data store in any region has to replicate and commit and then act back, which is going to slow down my application. But I get strong consistency, which means I get an RPO of 0 if any region happens to fail. Now, on the other end of that spectrum, I could choose, say, an eventual consistency. So I'm not blocking with a synchronous replication. It's all asynchronous at that point, and it's just replicated using unused resources for your account. The best part about that is that if a region goes down, I'm still available because I'm trading off that consistency for that data for the availability, right? So the way to translate this is customers, well, at least architects, should know, like, what is my RPO? What is the tolerance?
What does I wrote down RPO, like it's something that we should maybe know, but maybe you can help me out.
RPO is recovery point objective. Okay. And what that is a measure of time for how much data you can lose. So it's the point of time from where the data is made consistent, or you maybe have a backup, to when a disaster occurs. So that's your RPO. The other metric is RTO. That's recovery time objective. And that's the length of time that you can tolerate being down for.
Okay.
Now, customers will say, I have an RPO of 0 or an RTO of 0, but in reality, you can't have both RPO 0 and RTO 0, because in a distributed system, you can't have strong consistency and then also be completely available all the time.
And because these are trade-offs that you have to, these things are the way they are, and now you have to make objective decisions on where you want to be.
It's the physical universe. You can't cheat the speed of light. Right, and that's fundamentally what you're saying. If you want RPO 0 and RTO 0, is I want that packet to go from this region of the world to that region of the world and commit and come back and do it faster than the speed of light. You don't often have to think about the speed of light when you're designing applications, but in a distributed system, when you can have replicas or nodes that are separated by hundreds or thousands of miles or tens of thousands of miles, it takes quite a while for a packet of data to go over a wide area network and then come back again.
So, by the way, I forgot to mention, if you have questions, you can go to aka.ms, MS Ignite Live. We can ask Mark Brown all the questions about these kinds of things. So as I'm looking at this, what are some principles that I can use to decide between RPO and RTO? Because obviously, like, look, I'm a programmer and I get smells about I should, do this trade-off. Should I use more RAM or use more compute? You see what I'm saying? And we have this sense about those things. How can we develop that sense for these kinds of challenges?
Something like an RPO and an RTO is really a business-driven metric, right? What is the cost, the opportunity cost for being down versus being up? Now, if I'm a retailer and in a couple of weeks we got Black Friday coming, what do you think my tolerance for downtime is going to be?
Probably 0, because every second you're losing probably millions of dollars for some people.
So your trade-off is going to be an RPO in that sense, because you have to have complete uptime all the time, right? Versus, I don't know, maybe an insurance company or, I don't know, another type of institution where they can tolerate a little bit of downtime. And we may only be talking about a few minutes, but they absolutely, positively cannot lose any data when they commit their data.
I see, and that would be like a financial institution. Possibly. For example, if the credits and debits have gone in and the system goes down, those need to be there.
Yep.
Okay, so let's talk about how Cosmos DBs helps you slider that trade-off a little bit.
Right, so the consistency levels is the one trigger or slider that you have, right? And choosing between a strong consistency or the next one would be a bounded staleness. So what this does is it says, I can tolerate dirty reads over some period of time or some number of updates, and it'll always lag behind that, and then Cosmos will make that consistent within those parameters that you define.
Hold on, I think you went really fast, because I had this, we have available or consistent, and for me, it was like this one or that one. Now you're saying that Cosmos DB lets you do some ranging in between.
Yeah, we have 3 more inside that.
See, now this is interesting, right? Because I want people to understand this, because the first time I saw this, I was blown away that there's some serious distributed system knowledge happening in Cosmos DB, and we get to take advantage of it with a slider.
Right.
So why don't you go a little bit slower, right? Because I feel like this is amazing information, amazing things that we can do, but we kind of don't realize how impressive this is. Because when I used to write these things in college, we had to do a lot of work. But for us, it's a slider. Why don't you tell us there are 5 different consistency levels, right? If I'm right.
Yep.
Tell us the 5 and what they represent.
So strong consistency, that's essentially synchronous, right? So if I write data into East US, and I have an account in East US and one in West US, and I use strong consistency, every time I write data, I have to synchronously replicate that, commit it, and then ACK it back before I can do anything else in the system.
And this is the thing, like people think, oh, I want that. But that might not be the case.
Not if you want a lot of throughput, because you can't do anything else in the system while that's happening.
I see.
Right.
Yeah, and like, if your availability areas are ones in the US and ones in Europe, you have to wait for the stuff to travel, right? And that's a problem.
Hundreds of, maybe thousands of milliseconds.
But if you're a bank, that is a trade-off you're willing to make.
Maybe it is.
In some cases. All right, so let's go to the next level.
So the next level is bounded staleness. So this defines your consistency by either a period of time or a number of updates. So you will always lag behind either one of those 2 variables there. Now for a 2-region deployment, so let's say East US and West US, that minimum is going to be about 5 minutes or 100,000 updates.
I see. And so can you change that number?
You can change it, you can increase it, you can't go any less than that.
Okay.
But your RPO at that point is at a minimum of 5 minutes, which is a pretty small window.
Right.
Right. Next is the session level of consistency. This is the one that most customers use. It's the default in Cosmos. What this does is it provides strong consistency within a single session, within a single region for an application. So essentially you read your own writes within Cosmos DB.
And that's useful in a situation where you have a customer interacting with you in that region, and it's okay if everything's in that region and it'll stay consistent in that area.
That's why it's the default and why it's the most used, is because typically for distributed systems, the customer is always going to be talking to the same region.
Right.
Right, so that's generally okay. And even if they're using multiple load balance versions of their application, you can still share that session token between them, so no matter which instance of the app you hit, they're always going to get their own data back.
Which is cool. And then what's the next one? There's one more, right?
One more, consistent prefix. So this is a more relaxed level of consistency, more like an eventual consistency, except the updates you see are always in the order in which they were made. And then eventual consistency, and as the name implies, everything will be consistent eventually.
Right.
And there's no guarantee on which order I see things. So I could write 1, 2, 3 and see 2, 3, 1.
And that could be a problem in some applications, and another it really isn't, like if you're making a new Twitter, for example.
Or a scoreboard for like golf.
Yeah.
Like have you ever seen that completely up to date? Not really.
Yeah.
Right. So that's a good, or baseball game, that's a kind of a classic example we use. Like everything is eventually consistent. It's okay, you just follow the main scoreboard and you get the score you want.
And I like that, for example, in Cosmos DB, it allows us to choose that, because for one, it helped educate me about these things. And then number 2, it allowed me to make an appropriate decision based upon the application that I'm building with Cosmos DB. Because the only thing, and we only have like 2 minutes left, but I wanted to get into this a little bit. The other thing about Cosmos DB that's interesting is that it allows you to choose how to save data to it.
Yep.
Can you tell us a little bit about that?
What do you mean?
Like, for example, you can use like a Mongo style thing. You can use a graph database style thing. Tell us about those. I don't know a lot about it. I'm hoping you can educate.
So we're a multi-model database. So
there you go.
Underneath, we're a JSON store, right? And we have our native format. It's called our core SQL format. But we also support other formats as well. So Gremlin is another format for graph databases, and that's a very popular database for customers to use. We also have support for Cassandra. So if you are using a Cassandra and want to migrate over to a cloud environment where you're globally distributed, you get all of the goodness for Cosmos DB, you can use us. MongoDB is another one that we support as well. We also support the classic table storage as well. And then a new one is etcd. Is a new one that we've built. We haven't made that available kind of where you can provision out of the portal, but we built it to provide the backing for Kubernetes storage.
Yeah.
And so that's really exciting. Now if you've got today self-managed Kubernetes, you can use Cosmos DB to offload basically the config store into Cosmos. And so all of that can happen there, and you get all the goodness of low latency and high availability.
And the thing that's cool about that with Kubernetes is one of the hard things with distributed system is storing data reliably.
Right, and what happens if your master node goes down? Boom.
Yeah, and it's cool that you're able to sort of back that up. And so I love Cosmos DB. I love the ability to actually use it in a way that I'm used to if I'm either using Cassandra, Gremlin, whatever. So thank you so much for spending some time with us.
No, you're welcome. Thanks, Seth.
This is awesome. All right, so let's go out to the .NET corner for a community report on productivity tips and tricks with IntelliGo. Did we do that one, or are we doing something else? Are we doing that one again? Okay, well, let's go somewhere, and let's